In this video, we are going to study the message passing model. So, what is message passing model? So, we are studying in the third unit is IPC, interprocess communication. So, there are two models we are going to study under this. The first one is the shared memory system, and the second is the message passing model. So, we have already studied the shared memory. So, this is the second model of our IPC, that is message passing model. So it is a message passing model. So as you know that in a shared memory system, we are going to exchange the data between the cooperating processes by sharing the memory. So hence the model name is a shared memory. So what is going to happen in the message passing model is, here we are going to communicate with the processes are going to communicate with each other by sending the messages without using any kind of shared memory. Clear? So for example, a chat program in our world wide web or in mail, there is a chat program. So that is an example of this message passing model, you can see. So if two processes, for example P1 and P2, wants to communicate with each other, there should be a communication link. So in message passing model, if two processes wants to communicate with each other, there must be a communication link between the two processes. Clear? Even for sending the message and even for receiving the message. So how you are going to, or what is the use of this communication link means, just for communicating between the two processes, we are going to establish a communication link. So if already a link exists, so no need to establish it once again. Okay, so now whenever we are going to start the exchanging the messages between the two processes, we have to set here the two basic primitives, that is send and receive. So what is the syntax of your send here? A send contains a destination process and the message. So destination process is nothing but we are sending a message to which process, that is nothing but the destination process, and message is nothing but the what data you are transmitting. And similarly a receive is nothing but a second basic primitive. So receive contains here the source process and the message. So source process is nothing but from which we have got the we are receiving the message. Okay, and message is nothing but what message we are going to or we are received here. Okay, so now, so the important thing in the message passing model is you need to remember here the whenever the two processes wants to communicate with each other in message passing model, there is no need of any shared memory, just we need here the communication link. Okay, so communication if already exists, then no need to establish. Then how the communication link is going to establish? By using this send and receive primitives. So now again there are three ways how we are going to establish the communication link. So that is direct or indirect, and synchronous or asynchronous, and third one is the automatic or explicit buffering. So we'll see one by one. So first one is the direct or indirect communication. So what is a direct? First we'll see a direct communication. So in this, a direct communication is what here? Under the direct communication, if the two processes wants to communicate, then the both processes needs to name other to communicate. Means we have to specify here the names. Clear? So for example, if two processes, for example A and B, wants to communicate, then here the what I told in the last slide is two basic primitives we are going to require whenever the communication we want. So in that, a send B. So B means what here? A destination. So to whom we are sending the message? So to which process we are sending? To the process B. And message is whatever data you want to send, that data you need to mention. And similarly a receive is nothing but from which we are receiving the message, from the A. Clear? And so now a link is established automatically between A and B whenever we will send these two basic primitives, and a link is associated exactly between the two processes, not more than that. Just remember this. Between each pair of processes there exists exactly one process. Suppose A and B wants to communicate, then there is only one communication. Suppose B and C wants to communicate, then there should be only one communication link between the B and C. Clear? So again, the direct communication is also known as asymmetry addressing. What is the another name of direct communication? The another name of direct communication is symmetry addressing. So why we will call this direct communication as a symmetry addressing? Because both the sender and receiver process are going to specify the name to the processes whenever we want to communicate. That is because both the sender and receiver process must name the other to communicate with each processes. Clear? So next is the indirect communication. So indirect communication is what? Here only a sender is going to specify the names, or here only sender names the recipient. The recipient is not required to name the sender. So what is the basic primitive we have used in the direct? Send and the process name, that is destination process, and the message. So same is there, but in receiving, so as I told in the indirect communication, only sender is going to specify the recipient name. The recipient is not going to specify the name of the sender. So hence the receiver is going to specify, or receive primitive contains the ID and message. So here what is ID here? ID is nothing but a variable. It is used to set the name of the process with which the communication is going to be taken place. Clear? ID is what? ID is a variable. ID is a variable used to set the name of the process with which the communication is going to be taken place, or the communication has taken place. Clear? So in this indirect communication, the messages are sent and received from the mailboxes. So what is mailboxes here? The mailboxes are viewed as a you can say an abstract object. Okay, the mailboxes are an abstract object. Into this messages may be placed and from which messages may be removed. The mailboxes is what here, as usual in our Gmail we are going to send and receive the mails, right? So same, mailboxes are nothing but an we can view it as an abstract object where we are going to place and when we are going to remove the messages. So each mailbox is having a unique identification number, that is nothing but ID here. Clear? So now the second communication to establish the communication link between the two processes is synchronous or asynchronous communication. The message passing may be either synchronous or asynchronous. The another name of this is also, we call it as a blocking or non-blocking. Synchronous is nothing but a blocking and asynchronous is nothing but the non-blocking. So here we'll see a blocking send. As I told, there are two primitives we are going to require here. There is a require of two basic primitives, send and receive. So similarly we are talking about a blocking and non-blocking. So if we are sending blocking and non-blocking, so we have to, so what is blocking send here? So blocking send is nothing but whenever suppose the sending process is in this blocking send, the sending process is blocked until the message is received by the receiving process. Clear? The sending process, the blocking send means what? The sending process is blocked until the message is received by the receiving process. Means the sender, that particular sender will not send the one more messages to some other process. It means we are going to block that sender process until the message is received by that specific receiver, you can say. So what is non-blocking send here? The sending process sends the message and it can resume the operation here, or means the sending process sends the message and it can restart the operation here. So it is blocking receive here, the receiver blocks until a message is available. Receiver is going to block the message until it is available. Means suppose the sender has sent already a message and the receiver has not yet received, means and again the sender is without knowing the whether it has received or not, still if it is sending, then it is the receiver is going to block it just for a temporary period, you can say. Then what is non-blocking receiver? The receiver is going to retrieve or it is going to access either a valid message or a null. Here we are not going to block anything here. So it is a third way to establish a communication link between the two processes, automatic or explicit buffering. So whatever we are exchanging the messages between the processes are going to reside in a you can say in a temporary queue. Whatever the messages are exchanged between the processes are going to be stored in a temporary queue. So these queues maybe of these queues can be again implemented in a three way, that is zero capacity. So what is zero capacity is here the queue is having here we are discussing about the length of a queue. Here the queue in zero capacity, the queue is having the zero length. So now in this communication link we cannot have any message in the waiting period or in waiting state. Clear? In this zero capacity means the queue is having the maximum size of 0, so hence the communication link cannot have any message in a waiting list. So in bounded capacity, the queue is having the finite length of n, means suppose the queue is having 5, the length of that queue size is a 5, means in this 5 messages can wait. Clear? In bounded capacity, the queue has a finite length n, means n number of messages can wait under it. So in this bounded capacity, if the queue is not full, whenever a new message is sent, the message is placed in the queue and sender can continue execution without waiting. If the queue is a full, sender must block until space is available in a queue. Means what? Bounded capacity, if the queue is a full, in bounded capacity the size of a length is a n number, means n number messages can wait under this. So if the queue is a full, the sender must block here until the space is available. So if the queue is not full, the sender is going to transmit or send the new messages, okay, and those messages will be placed in the queue. That's it. In unbounded capacity, there is you can say the length of a queue is here infinite, okay. So thus any number of messages can, or how much in this any number of messages can wait until this. The sender here never blocks because the capacity of this queue is infinite, okay. So now the name of this communication link is automatic or explicit buffering. So we have discussed here the three types of queues, that is zero capacity, bounded capacity and unbounded capacity. The zero capacity case is referred, or you may call it as the zero capacity is referred as no buffering, okay, or explicit buffering. And other two cases, that is bounded capacity and unbounded capacity, are known as the automatic buffering. Clear? So this is the message passing model, that is the second model of a IPC. Okay, thank you.